Ladies and gentlemen, it's a pleasure for me being here today and being able to talk about the Rohde&Schwarz ScopeRider, our new digital handheld oscilloscope. My name is Markus Hördin. I'm product manager in the oscilloscopes division and particularly caring about this product. I have prepared a presentation for you, giving an overview about the features of the product and also why we decided to develop such a handheld oscilloscope. I have as well two variants of this handheld scope with me. On the one hand side, a 2-channel model with an integrated multimeter and a 4-channel model, which I will use then later for a live demonstration where I can show you some of the features and some of the advantages of the scope. But let me start now with maybe an overview and then motivation of why we did that. So you might have known Rohde&Schwarz as a specialist in high-frequency electronics, measurement instruments, and so on. You might not yet know to full extent that Rohde&Schwarz did enter the oscilloscope market. That happened already 6 years ago, and we have a quite broad portfolio that we established during those 6 years. Yeah? And as you can see on this slide, it reaches from the value segment, so entry scopes that can be used in schools, that can be used by hobbyists, but already have a lot of capabilities, up to high-end scopes that can be used for very specific tests that you have to do in the laboratory, and from frequencies that we cover, so from 50 megahertz up to 4 gigahertz. Yeah? This oscilloscope portfolio was developed during the last 6 years, essentially, and we leveraged here on the know-how that Rohde&Schwarz had in digital signal processing, in front-end design, and of course in embedded electronics. And at one point in time we decided, well, let's take this know-how that we created and the things that we learned here and move it in another segment, yeah, where there has not been a lot of innovation in the last years. And this is the handheld oscilloscope segment. Yeah. So, that was the decision where we said, okay, let's take that, let's put this know-how in a portable, compact device, and that was the reason why I developed the Rohde&Schwarz ScopeRider. If you look at what handheld scopes did deliver before, or what was available on the market, you can also see the reason why we think this was important to do. Handheld scopes have been available with bandwidth up to 500 megahertz, but when you look to the details, you see 10 kilosamples of acquisition memory, an acquisition speed in the order of only 10 acquisitions per second. Mixed signal not available in those scopes, protocol trigger and decode not available, spectrum analysis usually very basic in handheld scopes. Display technology was still often sub VGA and remote control relatively basic. So to cut a long story short, there was quite a big innovation step already between what was available in the market and what you can deliver. You know? This is one part of the story. The other part of the story is that when you look at applications and two-day electronics in today's market, there is a lot of electronic also used in all kind of field applications. Yeah, just imagine of some IT centers where you have to make sure that power supply is really always there. You have to make sure that power quality is sufficient. Yeah, or let's look in robotics. Yeah, where you have advanced electronics that is used in a manufacturing at the manufacturing site, and you have to make sure that it works there and that you can debug troubles, debug problems that are existing there. So when you think of those applications, you immediately see that it would be great to have a laboratory scope, but in a compact format. And this is what we did. Yeah? We said, okay, let's take the know-how that we have and let's develop a lab scope that you can take with you. Yeah? And this is what we did with the Rohde&Schwarz ScopeRider. So what does this instrument offer? Well, number one, and I think this is the one key message, it is laboratory performance and laboratory capabilities. Yeah? So, and I will touch this through my talk, and I will also demonstrate this in the live demo. So there are things that you usually only had available in the lab that are now available in this compact format. Number two, an oscilloscope is always a troubleshooting device and a multi-purpose device. Yeah? This is even more the case if you look at field applications, yeah? Because you go to a manufacturing site and you have to debug the problems that are there, and you don't know exactly what you will see there and what you will find there. Therefore, it's important that you have as much capabilities and as much performance with you. So we decided therefore to put a lot of things into this device, and this is why we created these 5 instruments in one. Yeah? So essentially, what do we have here? We have, of course, the lab scope. We have a logic analyzer integrated in the scope. We have a protocol analyzer for serial protocols. We have a data logger, and we have a digital multimeter. And this offers you a lot of troubleshooting capability for the field. Well, on the other hand side, when you arrive at one of those sites and you have to understand what is the problem here, how do you troubleshoot, you don't want to fight with your scope. Yeah? So you want to make sure that usability is not a problem, that you don't want to read the manual before. So there was a strong focus on let's make this instrument usable like a smartphone. Yeah, let's make it intuitive to use. And that is the reason why we integrated a touch display with a very good resolution, but still other elements. So there's still a keypad available. There's a multifunction wheel available. So there is a very easy way of controlling the instruments, and you can see that also when you look to the details. Yeah? For example, the menus are only up to maximum 3 levels deep. Most of the things can be accessed directly with one key press. Yeah. A handheld oscilloscope is used in all kind of environments. Sometimes you want to look at electrical installation. Sometimes you want to look at electric drives and at the same time look at the electronics. And when you think of such applications, you understand that it's very important that safety is there. And this is guaranteed by the isolated input. So we have isolated inputs on all channels. They can be used or certified up to category 4 environments and up to 600 volts category 4 or 1000 volts category 3, which means there is no safety problem when working in such environments. On the other hand side, also the interface section, like the mixed signal section, is isolated against the other input channels. So you can work on drive electronics at the one hand side, and you can debug digital control signals at the other hand side and understand what is happening, what is the correlation, without any problems. Well, and of course it's the scope is robust. So you can imagine Rohde&Schwarz has a lot of equipment for many different applications. So we test some of our equipment to military standards, and this happened as well to this handheld scope. Well, and last but not least, there is much more that is available in the scope, and one of the interesting things here is a wireless LAN hotspot. This can be used in order to control the instrument from the distance. Again, when you now think about environments where it's difficult to be at the actual measurement site, or maybe it's dangerous at the actual measurement site because of the voltages, in such situations you can use the wireless LAN access point and control it from the web browser of your iPad or from your notebook. Well, so this is an overview about the key topics, and I will now deep dive to some of the topics, and then I will go through a demonstration. Yeah, one thing that I missed here is it is available from 60 to 500 megahertz in several steps, and of course as a 2 and a 4 channel model. So number one, superior performance. Maybe the most or the easiest way to demonstrate the performance of a scope is acquisition speed. How fast can an oscilloscope acquire one waveform after another, after the other? Well, for the ScopeRider, we achieved something that was only available in lab scopes before, and this is 50,000 acquisitions per second as a maximum. Yeah? And this is important if you want to look at signal problems, signal faults that do not happen all the time. So in the example that is shown on the screen, you see a clock signal, and actually you see many acquisitions of a clock signal plotted just in one screen. Yeah? And you see one signal that looks different. Yeah? And this one signal happens only relatively seldom. And this is only possible to find this one signal because of the acquisition speed. Yeah? And I will show you later in the demonstration part how you can how this can be used and how it helps you to point you to the problem and then to debug further and understand what is really the issue with the problem that you are troubleshooting. Well, other things that we integrated because we think that they are very valuable for applications of this scope is a low-pass filtering, which is basically can be used for signal enhancement on the one hand side, but also to get rid of higher frequency content that you don't want to see. Yeah? So in drive applications, for example, sometimes you only want to look at 10 kilohertz bandwidth, and that is the reason why we integrated, in addition to analog filters, also digital filters with many different steps. And so you can choose between bandwidths from 1 kilohertz up to the maximum. 350 megahertz would be the maximum filter bandwidth, and 500 megahertz, of course, is the maximum bandwidth of the scope. And you can just tailor it to your needs. Superior performance also is visible when you look at the trigger system. So this is the first handheld scope that has a digital trigger system. This means that the trigger system sits after the AD converter and sees exactly the same signal as the oscilloscope is seeing. This is not the case for traditional oscilloscopes with an analog trigger system, because there is a difference between the analog signal path and the signal path that goes through the AD converter, which translates for normal scopes into trigger jitter or some inaccuracy in triggering. Well, we took this digital trigger know-how that we had from the lab scopes we developed to this handheld scope, and have now the possibility to have a lot of trigger functionality exactly happening to the data that is then processed by the scope. And this trigger functionality translates to 14 trigger types, which allows you to isolate exactly the signal detail that you want to see. Yeah? So trigger types that you have in addition to the standards like edge or glitch is width trigger or pattern trigger, data to clock trigger, timeout trigger, and protocol trigger, of course, which is then for serial protocols like I2C or UART. On this slide, you can also see the aspect of usability that we integrated in many different ways in this scope. Yeah? So we have for the trigger types and also for the measurements and many other settings, we have diagrams that explain how this particular function is working. So usually it should not be necessary for you to go to the manual and read how does even a complicated trigger function work, but you can understand from the diagram and therefore quickly and easily work with the scope. Well, another thing that is important and valuable for scopes are automatic measurement functions. So we decided to put a lot of measurement capabilities into the scope. So in total it's 33 different measurement functions. Again, you see that we have diagrams for specific functions. So in this example, it's the overshoot measurement function, and you easily understand from the diagram, this is exactly what this measurement function does measure. You can use up to 4 measurements in parallel. They are displayed in the top left corner always. And you see additionally that the C1 in this example is the channel indicator, which shows you what is the channel that you're currently using for the measurement. Yeah. Well, and apart from the measurements, of course, you can do measurements with cursors. They get also shown on the same place in this screen. In this example, it's a track cursor where you measure the values and delta values and delta time at the same time. Zoom is something that, well, essentially only makes sense if you have enough memory available. When you remember the beginning of my talk, you might remember that scopes typically had only like 10 kilosamples in the handheld segment. We decided, so we said, okay, well, 10 kilosamples is not enough for providing significant zoom capability. So we decided to give a lot of memory into the scope for this segment, so it's 500 kilosamples. And you can see from this example that this was a LED driver startup that we analyzed here, that it allows you to go into the details of the startup behavior. Yeah? And how this works is, well, first, and this is the basic concept for the scope. First, you press the zoom button, the zoom gets enabled. Yeah? Then you can change the zoom factor with the wheel to exactly the zoom factor that you need. And then if you press the middle button of the wheel, you change to the pan function. So you can then move around and move the zoom window exactly to the position you want to see. Yeah? And this concept of pressing the buttons and then enabling the function or disabling the function again, this is the same through the whole instrument and makes it really easy to work with it. What else? You might know history functions from laboratory scopes. So history functions are usually a way of storing past acquisitions and are very useful to look at events that you just missed. Yeah. So maybe the scope is running and you see that there was now a signal that you didn't expect, but it's gone. Yeah. In such cases, you can use the history function, which automatically collects those past acquisitions, and you can scroll back in time. Yeah. And this is what we did here. Different to other scopes and competitor scopes, we do not only make history with a memory segmentation, but we have a separate memory in the scope for this history function. So on top of the 500 kilosamples that you have for waveform acquisition, we have 12.5 megasamples of segmented memory available, which is used for this history function. Yeah? So you don't lose memory depth when you use the history function, at least not up to some point. And this history function can store up to 5,000 segments with absolute or relative timestamping. And this is also a very nice feature for this function. the whole scope functionality is available on all those past acquisitions. So you can scroll back in time and look at the signal there and then analyze this part of the signal with all of the function that the scope has. Applications for such a feature is, of course, acquiring data on the one hand side over long time periods, where maybe you also want to capture short data packets, but over a long time, and you can do this very easily with the history function. Then, of course, saving events that you just missed, and then scroll back and analyze. Yeah, and in general, serial communication or pulsed signals. Yeah, basically the history mode is available through a dedicated menu, and it allows you to select the replay speed or number of segments and so on. But I will go through that later in the demonstration part. And yeah, what you see here, what was just as you can be seen here in the presentation, is the history replay function. So you have either the timestamps where you know when exactly was this acquisition captured, or you can add in an absolute or in relative way. Yeah, then topic number 2, which we think is important for this scope, is the 5-in-1 capability. And since, if you have 5 instruments in such a scope, and maybe there are more functions that get integrated in the future, it doesn't make sense to have everything available with different buttons on the scope. But we decided for a central mode button, which then brings up this mode menu and allows you to switch. Yeah. So basically, in the scope mode, you have the scope, the protocol analyzer, and the MSO, so the mixed signal analyzer. In the meter mode, you have the digital multimeter, the data logger in the logger mode. And then we used this concept also to have some kind of sub-modes. Yeah? For example, there is an XY mode, which shows you, in addition to the XY diagram, also the X and the Y signal at the same time. And that is quite convenient for applications where you need an XY diagram. Or there's also a separate mode for the mask test. Yeah. Well, the MSO option, looking at that, it is an 8-bit digital MSO that is available with the scope, in addition to the analog input channels. It has 200 megahertz bandwidth, 1.25 gigasamples per second sampling rate. So it is a lot for many applications that you where you want to debug digital signals at the same time. And the MSO option has a separate sample memory. Yeah? So it does not take the sample memory of the analog input signals. The interesting part here is that it's isolated against the analog input channels, as I mentioned before. This means you can look at kind of dangerous voltages with the analog input signals, and at the same time at the digital input signals that are maybe control signals, yeah, and understand what is happening in both worlds. The protocol analyzer is a hardware-implemented trigger and decode protocol analyzer, which allows direct triggering on protocol events and data, and on things like packet start or packet end. Yeah. And today we support I2C and SPI, as well as UART, but there is more to come. Well, the digital multimeter, this is basically available in 2 variants. So if you have a 2-channel model, you have a true multimeter with AC-DC voltage, AC-DC current, if you have a probe or shunt, capacity, diode test, continuity, resistance, and temperature. If you consider the 4-channel model, then you have a digital voltmeter via the oscilloscope inputs. Yeah. And this is shown here now. For the 4-channel model, then you can look at all the channels at the same time. Well, it offers the things that are usually available or are important, like min, max, average display. Well, we have on-screen buttons which allow easy control of the multimeter, and also relative measurements. The data logger allows to make long-term measurements with the scope. So it is based either on the oscilloscope measurements or on the digital voltmeter or digital multimeter measurements. And it takes those measurements and logs them for a very long time. And very long means up to 23 days with an additional and separate acquisition memory for this data logger of 2 megasamples. Yeah. It allows 1, 2, and 5 measurements per second, relative and absolute time stamping, and it has a similar user concept as for the scope. So, for example, the zoom function works exactly in the same way. When you press zoom, it's enabled, and then you can pan around if you want to zoom to a specific position. Yeah, these are like the positions where you see min, max, and timestamps. The zoom, now in this example, the zoom is activated. Yeah. Okay. Well, usability was one of the important aspects that I talked about before. So our goal was to make it intuitive to use. And intuitive to use means, well, of course, the touch display and having it controllable on the touch, like a smartphone. Yeah. But also many other elements like top and bottom status bars, which show measurement results and channel settings always in a very clear way and easy to understand way. This is, for example, by using color coding. So a specific channel has always a specific color, and this color is used in all the settings so that you always know you're working with channel 1, channel 2, channel 3, channel 4, and many other details like large numbers and small fonts for the units for better readability. Well, I mentioned the graphics that we use in, for example, measurement or trigger setups before. We have this multifunction wheel. Yeah, this is actually a very nice thing because it allows for a very fast adjustment of some specific functions, like for example trigger level. We have dedicated autoset and preset keys. This is well, both are really important. Autoset is obvious, yeah, because it provides you with a nice setup immediately without trying to find what is the right setting for the scope. But also preset is very important because even it's easy to use. There are a lot of capabilities in this scope. Imagine you enable one of the bandwidth filters and you forget that you enabled it, and then you will not understand why doesn't the signal look kind of strange. Yeah? So the preset allows you to start always from one specific point without any unexpected settings of the scope. We have the central mode button that allows you to switch between the instrument modes. And last but not least, we made relatively large buttons for the keypad, because some people will use the scope in places where they want to use gloves, for example, yeah? And then the keys have to be large enough. Yeah. Yeah. Before I was also touching the topic of protection. Yeah. Protection means we can go in all measurement environments up to category 4. And category 4 means that you can measure before the first views of the electrical installation without any safety risk. Yeah? And this is important if you want to debug, for example, the electrical distribution network for your manufacturing hall. If you want to understand, does the power supply look like you expect it, or are there any problems? Yeah? This is possible because we have isolated channels here. And as you can see in this diagram, the channels are isolated from the actual system, so the processor board, and are also isolated from the interfaces section. And the interfaces section is the section where you find the USB or Ethernet port, but also the MSO logic probe. Yeah? And because of this isolation, it's possible to measure digital control signals at the same time than when you measure higher voltages on the analog inputs. Yeah, and the second element, of course, is the design and the ruggedness of the scope itself. So we decided for an IP51 housing, which was only possible because we have no fan. Yeah, so we don't need a fan in the instrument, and it is tested, if you look at vibrations, to military standards. Yeah, so you can see, for example, sinusoidal vibration tests, random tests, or shock tests according to MIL PRF 28800F standards. Yeah, last but not least, many other things, and one of the things is connectivity. So you have all the important interfaces in the scope that you need. USB port, in particular for saving data to USB sticks. LAN port, if you want to control the device via LAN. There's also a USB host for controlling the instrument via USB. There is a micro SD card integrated, so you can store data also on the micro SD card, and later then take that card out and transfer data to the PC. And there is a wireless LAN module integrated, so it allows you to remotely control the instrument. And this is something that is very convenient for example, dangerous environments. Yeah, last but not least, we have 13 languages because we want to make it easy to everybody to use this scope, from Chinese, Czech, English, and so on. So I think that we cover the most of the languages that are actually needed. Yeah, so we think that because of on the one hand side of the performance and the capabilities that you have in the scope, but on the other hand side because of the form factor and the ruggedness, it has really its home in both worlds. So in the lab, as an instrument that you can easily take from one place to the other, but still offers performance of a lab scope. Yeah? And in the field, of course, because it brings capabilities and performance that you had only in lab scopes before, now to field applications. Yeah? And that was not available on the market before. And this is also the feedback that we got already. This is something that people really like of this scope. Yeah. Well, this brings me now to the next part of this this talk, and I would now like to show you a few things on the scope in a live demonstration. You can see here a small demo setup that I prepared. We're using a demonstration board that can generate several different signals. That's connected to the 4-channel model currently with one probe here connected to that board. And when you look at the screen, yeah, because I already actually created it by pressing Auto Set, yeah, you can see that there is some flickering on the screen, yeah? And this flickering I mean, this is basically kind of a clock signal, or it could be a data signal, or whatever signal that you want to analyze, and where you want to understand, is there a problem or is there no problem? Yeah? And as you can see here, well, there are some things happening that you might not expect. Yeah? And these are, I mean, sometimes the pulse is shorter than it should be, yeah? And you can only see this because the scope is so fast, yeah? And this is exactly the reason, or the topic of acquisition speed, only because the scope actually shows you many hundred, up to thousands of acquisitions in each screen update. You can capture those relatively rare events, yeah? Just for a demonstration, in this example, when I look in the menu, I can see currently we have 20,000 acquisitions per second. This depends on the exact setting of the scope. If we change the time scale, you see we go up to above 50,000 acquisitions per second. Yeah. But let's go to the setting that we had before. And well, now that we understood that there is a problem, we can use the capabilities of the scope in order to analyze the problem, yeah, and understand the reason or what is actually happening here. So what we know from this screen is there is a pulse which is shorter than it should be. Yeah? So why not using the trigger system to exactly get this specific event? Yeah? So I'm pressing on the setup, on the trigger setup, and I choose the with trigger. Yeah. And I want to see the pulse that is shorter than something that I expected. So I say shorter, and when I look at the time scale, I can guess, okay, maybe it was 30 nanoseconds or 20 nanoseconds. So let's try 20 nanoseconds. Let's look if we find something shorter than 20 nanoseconds. Well, and there it is. Yeah, we see there is one pulse that is shorter than all the others. And since we were able to discover this because of the acquisition speed of the scope, we were able to tailor the trigger exactly in that way that we can isolate this problem. Yeah. And now when you change the time base, you can see, well, obviously this does not happen very often. Yeah? So it is really a rare fault that happens here, and that we could only discover because of acquisition speed. But let's now try to get more information about this signal problem here. And one function that is convenient here is the history function now. Because with the history function we can capture past acquisitions, and then we can analyze them later on. So this is relatively easily done. Let's go to the menu, and then let's go to the history function, and let's select 5,000 segments. Yeah? So let's say we would like to capture up to 5,000 segments, and I do now press enable, and you can see, okay, we are acquiring acquisitions now, yeah? And they are stored. Yeah? If I now press the stop button, I can get access to the whole history function, and I can see, okay, I have 816 acquisitions acquired, and I can scroll through all these acquisitions and analyze them now. Yeah? What is interesting in this case is how often does this kind of strange signal actually appear. Yeah? And in order to find out how often this happens, we switch to relative timestamp and look at the relative timestamp here. Let's go back to acquisitions, the latest one, so 0. So relative timestamp is 0. And let's now switch to the previous one. Yeah? And we see, obviously that one happened 30 milliseconds before. Yeah? Let's go one step further. That one happened 40 milliseconds before. So we now see that this signal problem happens relatively rarely. The previous one was 30 milliseconds before, and the one before was 40 milliseconds before. Now we know much more about this signal problem, and can try to understand what is the reason for that. Maybe there is something happening every 10, 20 or 30 milliseconds that influences this clock signal and generates the problem. Yeah? Okay. Let's switch to another function, and I will now, actually I will just use AutoSet to go back to the previous setting and show you some other things that are interesting here. So if you, for example, want to make measurements, you press on the measure button. A long press, this was a long press. It opens up the menu, and then you can select the measurements that you want to perform on this signal. For example, rise time, and then let's say I'm also interested in the maximum voltage. And then I would also like to know the frequency. So let's select, on 2 I wanted to have amplitude, and on measurement 3 place I wanted to have frequency. Okay, so we are now measuring those parameters automatically. And what you can do now, and this is very convenient, you can take those measurements and transfer to the data logger. Yeah. And this is done simply by pressing the mode button. So you get to the central mode menu of the scope and pressing on the logger function. And now those measurements that I just previously selected are automatically locked with the measurement speed selected. Yeah. Currently, when I look in the logger menu, I see there is 1 sample per second. I can change this when I press stop and say, okay, well, I want to have a higher update rate. Let's go up to 10 samples per second. Let's start it again. And you can see, okay, you now get 10 measurements per second approximately. And you can watch this over a very long time and understand, is there some kind of drift? Yeah, maybe you're looking at a drift in frequency, at a drift in rise time, or whatever for a longer period. And this is what you can do with this logger function. The logger function works for the oscilloscope measurements, but at the same time you could go to the meter function and say, I want to log something from the multimeter. For example, I would like to know the voltage. This could be, in this case it's not the case, but that could be the voltage of the electric installation. And you want to log that over a long time in order to understand, are there fluctuations? Yeah? And then you would go to this meter function, and again, so set up the function and then go to the logger menu. And then you will log this multimeter function over the time period that you want to look at. As another example, I would also like to show you the trigger and decode capability of the oscilloscope. And for that purpose, I use a different demonstration signal that I have on this demo board. And this is an SPI signal. You can see there are 2 probes connected, and one is the clock, one is the data signal. You can also see on the screen, obviously the upper one is the clock. The lower one is the data signal. In order to decode such a signal, I mean, that's relatively easy. We go to the bus function. You have a long press on the bus function, then you go to the corresponding menu. You open up the config menu, and there you can see I already set up clock as C1, the data signal as C2. We have the thresholds as TTL technology. And when I use these settings and enable, then I can just see, well, protocol decode works. Obviously the first one is 0, then I have a 03, then I have a C7 hex and so on. And I can now use all the things that are usually available with trigger and decode, like triggering on a specific data signal, on triggering on frame start and so on. Well, last but not least, the last thing I would like to show in this live demonstration is how to remote control the instrument. And for that purpose, let's have a look at the menu. I press now the central menu button, and you can see here there is a wireless LAN menu. Wireless LAN is already enabled, and we have a LAN hotspot that has now the name RTH and 101034, which is the serial number. And what I did now is I I just took this iPad and have connected the iPad to the wireless LAN hotspot, and I have opened up the web browser in the iPad. And you can see that you have exactly the same signal as you have on the screen on the iPad in the web browser, so you don't need any software installed. And you can click on the screen of the iPad in order to change settings and control the device remotely. Well, so that brings me to the end of the live demonstration. I have a few slides that I would like to show you now, and then we are coming to the question and answer section. So the ScopeRider family, so those oscilloscopes are available in two base models, 2-channel model and a 4-channel model, where the 2-channel model has this additional multimeter integrated, so a true multimeter. The bandwidth is chosen by taking the corresponding bandwidth upgrade, so you can choose, the base model has 60 megahertz, and then you can go to 100, 200, 350 or 500 megahertz. On the software option side or hardware option side, you have the mixed signal probe. This mixed signal probe is when you look at the instrument that is actually connected to the side. So on the sides of the instrument, you have the upper part is for the MSO option. So you connect a logic probe here, and then you get this additional 8 bits digital signals that you can analyze. And then you have several software options. So for SPI, TriggerDecode, UART, history, advanced triggering, and also wireless LAN and so on. Regarding accessory, I think there is a lot of accessory available from soft or hard carrying case. There is a car adapter so that you can charge the instrument in the car. There are different probes available, replacement battery and so on. What is also interesting, I mean, the product was introduced in January this year, but we still have 2 promotions running that are quite interesting. One dedicated for the lab, where you get for 4-channel RTH models, you get an additional software package for free, and that still runs until June 30th. And one is dedicated more to field applications, which has integrated, so for free for any model that you buy with a particular bandwidth, you get in addition the wireless LAN and web interface remote control, carrying case, and some accessory, and that also runs until June 30th, and that one is for the 2-channel ScopeRider model. So that's all from my side, and I hope that was interesting for you. And I'm available now, of course, for any questions that you have. Thank you very much.